I'm recording this. Okay, good day everyone. Let's start our chemistry lesson. And we would like to talk about the objective questions from MRSM 2012. So please get your question ready and your answers ready. Previously, you have already checked your answers. So now it's time for us to see what are the problems that you have. Okay, now from the group, you told me that you are having problem for question 15. So let's move to question 15. Now before that, before question 15, do you have any other problem other than 15? 1 to 14, do you have any other problem? Question 1 to 14. If don't have, then I am going to move on. Okay, now we are going to look at question 15. Okay, now the question shows you, the diagram shows 3 items, which is the cutlery, the cooking pan, instruments used in the hospitals. Now, which method of rust prevention can be used for all these 3 types of items? So first of all, we have to know what type of substance that make up this cutlery, the cooking pan, and the instrument used in the hospital. Do you have any idea? Actually, all this, they are made up of alloys, okay? What type of alloy? Do you have any idea? Someone? Respond, please. Any,
Stainless steel.
sorry?
Stainless steel.
Yes, it's stainless steel, correct. Okay, now, do you know what is the main element or the main metal which makes the stainless steel? Anyone? Do you know?
Iron, sir.
Iron, okay, yes. This stainless steel actually, it is made up of iron, iron and also carbon, okay, and also chromium. If it is steel, then it is iron and carbon only. If it is stainless steel, there is more. So you please check. Other than the chromium, what else? Okay. Now, we know that when we are talking about stainless steel, it is actually one type of alloy. That's why your answer is D, donkey. Now, I would like to draw your attention to galvanizing. Galvanizing means you are going to pair the iron with the zinc, okay? And at what condition you are using galvanizing to prevent rusting? Any idea? Any idea? Do you remember the zinc rooftop? The rooftop, that one? It is one layer of zinc and one layer of iron, okay? And we have discussed this previously. Why is the zinc can prevent the rusting of iron? Explain for me. Come give me a response about why galvanizing can prevent rusting. Any idea from you? I repeat my
Zinc is more
question.
electropositive than
Okay,
iron metal.
Katun say the zinc is more electropositive than iron. Everyone agree? If you agree, show me a light. Zinc is more electropositive than iron. Okay, good. What about you, Samyu? Do you agree with that? Okay, good. Now we continue. What can you tell about zinc if it is more electropositive than iron? Can we hear from Chia Yuan? Chia Yuan? When zinc
What
is more,
question, teacher?
sorry?
What question?
My question is, why can the galvanizing can prevent rusting? Galvanizing means the iron coated with a layer of zinc. Now, just now Kachun said that the zinc is more electropositive than iron. Okay, what can you tell next? What can you tell next, Sangeeta?
Zinc can displace iron, teacher.
Okay, can you use the word zinc can displace iron? Do you use the word displace in this case? Do you have a solution and you put a metal in it? No. If no means you cannot use the word displace. But we can say that when we are talking about electropositive, what does the zinc do? When zinc is more electropositive, what does the zinc do, Xavier?
The zinc, I don't know, sir. No idea.
Okay. Donates electron or accept electron?
Donates electron.
Yes. So the zinc donates electrons. When it donates more readily, when it donates electron more readily than iron, then what will occur? What process does the zinc occur now?
Oxidation.
Oxidation.
Good. Oxidation. Okay, now we can actually write an ionic equation to represent the process that occur. Okay, so this is the answer. Why can the zinc prevent rusting by using the method galvanizing? Actually, yesterday during one lesson, I mentioned about this also. That means you all have not watched the video. Waiting for what? Please, what I am telling is important. I don't simply give you work. Okay, now we continue for the next part where we are now going to move on to the next question, which is question 26, I think. Is it? We should be at question 26 now. Okay, now let's look at question 26. Which of the following polymer is suitable to make water pipes? Now, what is the polymer that is used to make water pipes? Any one of you? Making water pipe, what is used? Can we
PVC.
tell? Yes, we are using PVC. Okay. What is the long name of PVC? Our friend said PVC. PVC is actually polyvinyl chloride. Okay. Now, how do we get polyvinyl chloride? Actually, it is from the monomer. It is called as the chloroethene. This is the monomer. Okay. Now, how to draw this monomer? Everyone draw for me. Draw now. Okay. Have you drawn? And you should check your answer. Now, this answer should be chloroethene, right? 2 carbon atoms. Can you see the ENE? Double bond. 1 carbon atoms, how many bonds, Zichen? Zichen? Yes, good, 4. Okay. So now you are going to put in your chloro first. Chloro. Chloro means the chlorine. So you might be putting it here. So the other parts, it will be the hydrogen atom. Now check, how do I draw the hydrogen? Now this part, the hydrogen should be pointed to the center. Okay. Now this is the monomer. When it changed to become the polymer, you check which one can be the polymer with the chloro. You have only one, which is CCAT as your answer. Okay. Now if I were to ask you to draw the polymer, it can be like this. Okay. Initially, it is this double bond. Okay. Now, but when it is a polymerization occur, this double bond will break and 2 new bonds will form. 2 new bonds are here. Okay, next part. Now, here you are going to put in this, the initial one. Okay, now what you are doing, you are copying the initial, this one initially is there. This one initially there. This one initially there. This one, you push it down here. This one also push it down here. Why? Because you want to put a bracket with an N there. Okay, so this is our structure of the monomer and the polymer. Wait now, I admit your friend first. Okay, so this is the monomer and this is the polymer. I hope you get this. Now, let's look at this part D. Part D shows a type of polymer. From the polymer here, you draw a monomer. I repeat, part D shows a polymer. From the polymer, you are going to draw the monomer. Everyone draw now. This one, huh? Okay. Have you get your monomer? Have you get your monomer? I need someone to show me your answer. I want to see Sangeeta's answer. Okay, I'm sorry. I unmuted just now. Okay, now just now cartoon show the this his work on drawing this monomer of the polymer given. That is correct. You can actually just remove, undo your video. You show your video and you show your work there, or you can actually share. You draw on the whiteboard that I am giving you. I hope you can try to draw if you want. Okay. Now this is one of the repeating unit. This is another one. Okay. Now when we want to get the monomer, we are going to use only one repeating unit, which is this. Okay. Now, how are we going to do? I am going to do it now using the pink color. This is the repeating unit. Okay, so you copy back 2 carbon atoms. And we know that for the carbon atoms in between must have a double bond. So the carbon-carbon double bond is here. Up here, you just put back what is given. No need to change any place. Okay, this is your monomer of the polymer, okay, given to you. Now, what is the name of this monomer? Can you see? 1, 2, 3 carbon atoms with the carbon-carbon double bond. This is actually the propene. And what is the name of this polymer? It is actually the polypropene. Now, do you know what is the function of the polypropene? Anyone knows what's the function of the polypropene? Anyone? Shall we hear from Yuan Kai?
Plastic bag.
To make?
Plastic bag.
Okay. Now, for your information, polypropylene is not used to make plastic bag. Polypropylene is mainly used to make plastic bottles or plastic containers. Used to make plastic containers. The one which is used to make the plastic bag will be called as the polyethylene. The one which is used to make plastic bag, it is called as polyethylene. Another name, we call it as polythene. Okay, the monomer is what? From here, we know that the monomer is the ethene. Can follow? No problem, Okay, now we continue to the next question. And which is the next question? I think the next question will be question 27. Yeah, we are now going to question 27. Next part here. The diagram shows an experiment in which ammonia is released. Can you see damp litmus paper? What should be this damp litmus paper? What color should be this litmus paper when you want to test for the presence of ammonia? This should be the damp red litmus paper. Okay? Because ammonia is an alkaline gas. Mixture of solution Z and aqueous ammonium sulfate. You want these two substances put together to react to give you the ammonia gas. So what will be the substance? Now your answer here should be the sodium hydroxide. Why sodium hydroxide? Then I have to show you the chemical equation. You see here, you have ammonium sulfate. Formula NH4 bracket 2SO4. React with the sodium hydroxide, NaOH, you are going to get what? I use the method that I always say, cut half, positive, negative, cut half, positive, negative. Can you see these two? These two will form the salt, which is Na2SO4, with the ammonia gas and water being produced. Okay, you have actually learned about this. Please balance up the equation now. Okay, please balance up the equation later. After the lesson, you balance up. Now you learned this in your group, in your acid and alkali last year, Form 4 chapter 7, where you are actually talking about the alkali which can react with any ammonium salt. Alkali react with any ammonium salt, you will get ammonia gas, the water, and also the salt solution. Okay, can follow or not? I hope you can. Okay, now you put a 2 to balance up the equation. I think the equation is balanced. Okay, so your answer is A, apple. And now we are going to move on to the next question from your response, which is question 32. Okay, now we continue with question 32. Question 32 says that a compound has the formula as shown. Okay, now what is the name of this compound? If you don't draw the structural formula as what we have learned, you see 1, 2, 3, 4, 4 carbon atoms. The formula, you are getting the formula as C4. H how many? 3 plus 2, 5. 5 plus 1, 6. 6 plus 2, altogether C4H8. With the carbon-carbon double bond, do you see? Now, if I were to draw this out, what will you see is that I am starting with the CH3 first, the CH3. Okay, next will be the CH2. Okay, after the CH2, you put the CH. This is the CH, double bond, CH2. It is the same as how you draw the isomers for this. And what is the name? 1, 2, 3, 4 carbon atoms. What is the name? Should we hear from Kajian? 4 carbon atoms.
Build.
Yes, built. Okay. With the carbon-carbon double bond ended with what?
Butene.
Okay, butene. Can you see the functional group at carbon 1?
Build 1 tin.
Yes.
Build 1 in.
Good. This is built 1 in. Okay. Now, when you see the carbon-carbon double bond, this one, then we say that it is an unsaturated hydrocarbon. So part A and B is out. You have only C and D. And we are talking about changing the bromine water. Initially, the bromine water is brown. When you add to this, it will be turning colorless. That's why your number 32 answer is C-cat. I hope you can follow until here. Now we continue. We are now going to question 36. Okay, question 36. Now given to you is a few drops of aqueous potassium iodide solution and aqueous lead-2 nitrate placed opposite side of the damp filter paper. Now what does it mean? Meaning at one side the potassium iodide. What is the formula of the potassium iodide? Anyone? Cha Yuan, what is the formula of the potassium iodide?
Ki.
Yes, good, Ki. You are good already, Cha Yuan. Why no confidence? Okay. Now lead-2 nitrate. Should we hear from Jia Hui? Lead-2 nitrate. Jia Hui, woke up or not? Gibbon, can you please help your friend?
PbNO3 bracket 2.
Good, PbNO3 bracket 2. Now when these two substances add together, you cut half, positive, negative, cut half, positive, negative. Did you see that you are actually getting this and this to combine? The positive from the back, take the negative from the front, you are getting PbI2. Don't forget to do this one, Jichen. You always forget this. Take the number, cross it, take the number, cross it. Then you are getting KNO3. Okay, balance up the equation. You are going to put a 2 to balance up the equation here and another 2 to balance up the equation. Okay, now what is the color of this? It is yellow. That's why you get yellow precipitate. Now, how does this occur actually? Actually, these particles from the potassium iodide and the particles from the lead-2 nitrate diffusion occur. That means this is a higher concentration region of the potassium iodide. This one also higher concentration of the lead-2 nitrate. So from higher concentration region, it slowly moves. When it moves and it moves, we say that it is diffusion. And at this place, You want the precipitate to be formed. So what will happen? Collision will occur. Do you remember that when we are talking about a reaction to occur that produce product, actually there must be effective collision. This is the part that we talk about the effective collision. That's why your answer will be CCAT. Okay, now we move to question 37. 1 mole of compound J give 3 moles of ions in aqueous solution. Now what does it mean? Meaning the J, 1 mole of J giving 3 mole of the J ion. Let's say I talk about this. Okay. Now from an atom it can become an ion. It is very sure that I'm very sure that this is actually a metal. Okay. Now J reacts with ammonium carbonate. Can you see ammonium carbonate to give you acidic gas? When you see this carbonate, what type of acidic gas will be produced actually? What type of gas will be produced actually? Okay.
Carbon dioxide.
Yes, good. This is actually carbon dioxide. Now, just now, without looking at the second sentence, I said for sure metal, this is metal J. That one is without looking at the second sentence. But now with the second sentence, oh, I have to change my mind. Why? Because it can react with ammonium carbonate. From what you have studied, only the acid will react with the carbonate, right? The alkali cannot react with the carbonate. So we are going to get the answer, which is an acid. So part A is totally out. C is totally out. You get only B and D. So which is a more appropriate answer? The more appropriate answer will be D. Why? Because when H2SO4 dissociates in water, you are getting 2 mole of hydrogen ion and 1 mole of the sulfate ion. Now, from my explanation just now from the first line, actually, I have already made this conclusion too early. So this is what we have to learn. When you want to read the question, you read now from top to bottom first. Don't do like what I did just now. You see, I talked about this, okay? Actually, the 3 mole, how to get the 3? This is wrong. They want it to be like this. Can you see a 2 and a 1? So 2 plus 1, you are getting the 3. So this is the meaning, okay? While when you are having the ethanoic acid, this ethanoic acid, CH3COOH, when it dissociates in water, you are getting CH3COO negative and H positive. What you are getting is only 2 mole, 1 and 1. That's why the B is not the answer. Okay, now let's move on. We are now going to question number 43. Now look at 43. Question 43 says that the volume of distilled, they want you to get the volume of distilled water required to be added to this in order to produce a solution of 0.25 mole per decimeter cube of solution. Okay. Now, first of all, we have to know about the concept. What concept is this? This is actually dilution. Okay. Now, before we continue, what I need you to do is you please log out this link, log in the new link, and we are going to discuss question 43 from there. Okay, log in using the next link. Okay, thank you very much. I'll see you then.